All right, so this is a little video on the idea of the limitations, some technical aspects of logs and exponential functions and how they related, and kind of there's a couple things with log functions and exponentials, but mainly logs that give extraneous solutions, and people, you might wonder why. So I'll kind of give you the idea. So let's say we have, a to the x power equals y. All right, here's a few things. So first we say a is not equal to 1. All right, why is that? Well, this is an exponential function right now. Exponential function. All right, well, let's imagine that you have 1 to x power, and then you try to get y out of it, right? 1 to any power is always going to be 1. So you would have an x variable that changes to whatever you want it to be, but the y variable would always change to 1. It would always be 1. So essentially, this would just be a straight line, which is a constant function. So in this situation, that would not be an exponential function. It would be a constant. So this is the first little limitation you have to put on a. A cannot be equal to 1. All right? So what's another limitation? Well, let's imagine that a was negative, right? Now, and if I let a be some negative number, so negative a, and I say x equals y. So then as the value of x changes, let's just go a couple in the positive and the negative, right? So let's say -3, -2, -1, then we got 0 and 1, 2, 3. And you can let a be any number you want it to be. I guess in this case, we'll just think of it like a 2. Not that it matters. You can just think of it like a 2 here, just so you can kind of understand where I'm coming from. So if I said, all right, x is -3, that would be -2 to the -3rd power, which is be a negative number. It'd be like -1/8. All right. And then we have -2 to the -2 power, which is 1. So it'd be, you end up, because it's a negative power, you flip it, right? And it'd give you 1/4. So it'd be up here. And then the next one, -2 to the -1 power would be 1/2. So let's just, if this is 1 right here, let's say it's like right there. And then anything to the 0 power is 1. So then you're up here. And then to the first power, it'd be -2. So then we have -1. -2. As you can see, it gets weird quick, right? And then -2 to the 2nd power, that's a positive number, and that'd be +4. So then it's all the way up here. And you can see that this graph, it's not like it is a smooth graph that does like this. This graph is a graph that breaks instantly, and it just is going. It's just made of these little dots that alternate between all negative and positive numbers, which is not an exponential function. It's some other type of function. All right, so that's another limit we put on this, and we say that a, so the limit here says a has to be a positive number, so it has to be greater than 0. So there's 2 little limits that we put on this so far. The first one is a is not equal to 1, and then the second one is a is positive. All right. Well, then if we think about that, okay, let's say so a is not equal to 1 and a is a positive number. Well, that means something for y as well. So if I have a positive number, and we'll just imagine this a positive number not equal to 1, and I say a positive number to any power is going to remain positive. So that tells you that y has to be positive. In this situation, it's a y, but it could change. It has to be a positive number. So these two right here lead me to say that y is also greater than 0. And that's the y in this situation. That's just for exponential functions. How does that change for log functions? Well, let's switch this to log form. So if I take this and I switch the form to log form, it becomes log base A of y equals x, right? So, a couple things now. We still have the same limitations. Number one, A is greater than 0, and then also A is not equal to 1. All right. Now, another limitation here is that the same as before. Y, or really whatever we're taking the log of, has to be a positive number. So maybe, when we switch it to its equivalent log form, it looks like this. But if we switch it to the inverse form and it looks like this, then it's still whatever number you're taking the log of has to be greater than 0. It has to be a positive number. So that's a couple of things to think about when you're trying to understand logs and really the extraneous solutions that go along with that. Let me kind of give you one idea, right? Let's say that I have log base, 2, some number that's not 1, that's not positive, of, let's say, -3 equals x. And I'm like, what is this? Essentially, I'm saying 2 to the x power is equal to -3. 2 to the x power is equal to -3. Okay? 2 to any power, because 2 is positive, there is no power that I can put in here. It doesn't matter what number. It'll never give me a negative. You can put a negative number in there, it's still positive. You can put a big number in there, it's just bigger, right? You can put a small number in there, it's getting closer to 0, or, getting closer to 1. But it'll never be negative. So 2 to any power is positive. Therefore, if I have this right here, it would be an extraneous solution. All right, so keep this in mind. Keep this in mind when you're doing your problems. This is something else I'm going to keep talking about. So, that's just something to consider.